Okay, College Algebra 1.4, B as in boy, and we are on page 107 getting ready to look at parallel lines. And one of the things that, I guess really the only rule about parallel lines is you can tell if two equations are parallel if they're in slope-intercept form and their slopes are the same and the y-intercepts are different. So, for example, there's an equation in slope-intercept form. Here is another equation in slope-intercept form. Okay, a couple things that have to be true. The slopes have to be the exact same number, doesn't matter what number, but they have to be the same, and the y-intercepts have to be different. Doesn't matter how different, as long as they are not the same number. Okay, that's all there is to it. So you can look at two equations and know right off the bat if they're parallel because those are the same and those are different. Okay, so the key thing, slopes are the same, y-intercepts are different. So not too hard to remember that, but you might want to put that in your notes so that it's a real quick reference in order to make that determination. Okay, so that's parallel lines. Perpendicular lines, and you know perpendicular lines are two lines that intersect at a 90-degree angle or a right angle. And perpendicular lines, when written in slope-intercept form, okay, sometimes you have to put them in slope-intercept form, but if they are in slope-intercept form, like that, and then we have another one, that's a minus sign right there. Might help if I made that a little clearer, huh? Okay. So, what has to happen is the product of their slopes is -1, which means if I take my one slope times my other slope, I have to get -5/5, which equals -1. I have to get a -1. In other words, perpendicular lines, I don't care what the y-intercepts are, perpendicular lines, the slopes, have to be the slope flipped upside down with the opposite sign. Okay, so this was a 5/1. We flipped it over, we inverted it, we took the reciprocal of it, and we changed the sign. Alright, so let's look at another one. Y equals 2/3 x plus 3. Y equals -3/2 x plus 3. These are perpendicular because the slopes are flipped different. They're the reciprocals of each other. One's a positive, one's a negative. That's all I care about. If you can get them to that form and find out that that's true, then they are considered perpendicular. All right, so let's look at example 7. A, y plus 2 equals 5x. 5y plus x equals -15. They want to know if these are reciprocal or not. That's all they're asking you to do. Are they parallel, perpendicular, or neither? So remember, you put them in slope-intercept form. Okay? This is 5y equals -x minus 15. Divide by 5. Divide by 5. Y equals -1/5 x minus 3. So we're comparing that with this. What do we know? Well, you can look and all of a sudden 5, 1/5, those are reciprocals. This is a negative, this is a positive, so you know automatically that they're perpendicular to each other. Okay, let's look at another one here. 2y plus 4x equals 8. 5 plus 2x equals -y. Slope-intercept form, 2y equals -4x plus 8. Divide by 2. Y equals -2x plus 4. Okay, let's do this one over here. I'm going to bring this y over and move these to the other side. So y plus 5 plus 2x equals 0. Now let's move these other ones to the other side. Okay, so there's my slope-intercept form. There's my slope-intercept form. Alright, what do we know? slopes are the same. The y-intercepts are different, so therefore we know that they're parallel. Okay? If you get some where the slopes are not opposites of the reciprocals, or they're not the same, then you'd say they're neither parallel or perpendicular. Okay? Because that can be the case too. As is, looks like letter C. If you were to do that, you'd find out that that was the case. All right, example 8, it says write equations of the lines A parallel and B perpendicular to the graph of the line 4y minus x equals 20. So we have 4y minus x equals 20. And it contains the point 2, -3. All right, so what contains the point? The line that we're going to draw, that the first line that's parallel, and then second, the one that's perpendicular. They both go through the point 2, -3. So before we do anything else, we have to write this in slope-intercept form. So 4y equals x plus 20. Divide by 4, cancel y equals 1/4 x plus 5. There's our equation in slope-intercept form. Alright, so we're supposed to write an equation of the line parallel and then one perpendicular that goes through the point 2, -3. Alright, so we're trying to find a parallel line that goes through the point 2, -3, that because it's parallel, it's going to have the same slope right here and a different y-intercept. Okay, so what do we do here? We have the slope, so that's good. We know the slopes are the same. So now all we have to do is find the y-intercept. So the way we find the y-intercept again, we take those numbers and put in the place of the y. Oops. And my x, and we have a b. Okay, because this is a new equation. And minus 1/2, so 3, or -3 minus 1/2 is -7/2. That's what my b equals. So now I have y equals, my slope is going to be the same, -7/2. And there's my equation that's parallel. Okay, so again, all I did was put the original one in slope-intercept form, got it like this. I know the slope. All I need to know is the b. So I took the b right here. Okay, this is a different equation. This is the equation I'm trying to write one parallel to. So these are going to be the same slopes. Take the point here that this line, this new line I'm going to draw is going to go through, which is 2, -3. Plug those in for my x and my y. Solve for b, and I have this new equation. Same slope, different y-intercept. So if I were to graph this one and I were to graph this one, they would go, or they would have the exact same slope. And this one would go through point 2, -3. This one we don't care what it goes through, because we're looking for what the new equation is going to go through. Alright, so all that being the case, let's erase all of this, and I'm going to go ahead and do the second part. We're trying to find a line that goes through this point and is perpendicular to this. Well, I know that a line perpendicular to this is going to have a slope of 4/1, and it's going to have the opposite sign. So my slope is going to be -4. So in my y equals mx plus b, I'm going to get a -4x plus b, right? Because I don't know my b yet. I don't know where it's going to cross the y-intercept. So what I'm going to do, I'm going to use my y minus y1 equals m times x minus x1. And I'm going to put my -3 in for that. My slope is going to be -4, and I'm going to put a 2 in for that. Okay, so it gives me y plus 3 equals -4x plus 8. Get that 3 out of there. And there's my new equation. Okay? This equation, or the line that this equation represents, will be perpendicular to that because the slopes are opposite sign and reciprocals. And this line, we don't know about this one, but this line is going to go through this point right here. Okay, that's all we care about. All right, so there we go. If you look on the bottom of page 109, it gives you some terminology. I would make sure I had that information down. That is some good stuff that's going to help you, I think, to be able to remember what's going on here. All right, so let's go to mathematical models. And one of the things that you'll notice in the homework is I don't give you any of the word problems. There are a whole bunch of them in here, but I'm going to go ahead and skip those. So you're just going to be doing problems up through 74-ish, where you're given equations to solve and get used to. So anyway, that's it for 1.4.